Okay, let us see more examples still about the elasticity. Okay, a spring of natural length 2.4 meters and modulus 6 newtons was compressed to a length 2 meters. Find the thrust in the spring. Now, if it was compressed, it means that now the natural length is bigger than so. We now a length of to a length. So meaning in our solution here, our L is going to be 2.4 meters. They are giving us modulus I 6 newtons. Okay, so the one has to get the thrust. Now they are giving that was compressed to 2. Means that now to get x, we shall get the natural length. This, then minus this. It's going to be 2.4 and minus 2. Means that it was, the compression distance was 0.4 meters. So using our formula, that our T is equal to x over L. Now this is the thrust we want. We said if there is compression, this is thrust and this is compression. So this is what we call compression. So our thrust is going to be now the lambda, they are giving lambda I 6 times x 0.4 over the natural length 2.4. So our thrust now is going to be it's going to be 6 newtons. So that's the thrust in that spring. Pretty easy. When it comes to this, find the modulus of elasticity in an elastic rope with tension 300 newtons. So we summarize our tension in the rope. It is 300 newtons when it's extended by 50% of its when it extends by 50% if it's stretched. So they're not giving us the length, but they're giving the percentage at which it extends. Okay, so the one that's going to the modulus of elasticity L. So it means that now our L is going to be the natural length. But again, that's that it extends by. It means that now our x is going to be 50% of L. Simple as that. So being that here my x is going to be 50 over 100 times L. So my x is going to be 0.5 L. So using my formula now, my t equaling to lambda x over L. Now I have this as 300 to be equaling to lambda, which I'm looking for. My x is 0.5 L, the whole over L. Divide this and this. And divide this besides that our lambda is going to be 600 newtons with S. So that's it. That's how we handle it. They don't give you the length, but they give you the percentage of which it extends based on the natural length. That's how we handle it. I think these are very easy things. Okay. We come to this also. An elastic string of length L. So we are giving us the length as L was pulled and extended by. So by means that they are giving us X. So by 300 centimeters. If its modulus of elasticity is twice the tension in the spring, find L. So they are giving us that modulus of elasticity is twice the tension in the spring. What does this tell you? We saw this at the start. Whenever I start with lambda is twice the tension, it means that the length of it means that the string was extended to the length equal to its natural length. In simple terms, the length of that string was going to be the length of the string is going to be just this, then multiply it by 2. Simple. Okay, now let us see. This is going to be now, this is the extension. So these are now from here, from my t equaling to lambda x over L. So this t is t, this lambda is twice t equaling to 300 centimeters, which we can convert to meters. Okay, from here, I can start my x equaling to 300 centimeters, which is going to be 3 meters. So, there is a duster. Okay. So, after this, I think that is going to be 3 meters. But you see, when lambda is twice the tension in the string, it means that now our L is going to be twice L. The length now of that string is going to be twice L. So here, this is going to be 2, or okay, it's just 2 L from the start. Why? Because we say if lambda is equal to twice the tension of the string, it means that that length of the string is equal to the extended length. In simple terms, we have seen that this was multiplied just by 2. In simple terms, the length was 300 is just equal to 2. Or if that's hard, then you use this formula here, 2L. Then you can see this one is going to cancel this. Then this goes with this. Then it's that our L is going to be equal to 3 meters. So our L is going to be 300 meters. So you already note that. So let me put that note here. Note. Let me pause and then recognize where I see. Okay, this is the statement I wanted to make here. From the question you could ABC that. So, whenever I start lambda is twice the tension in the string, it means that L is equal to x. So from here we have put the answer straight away. So that is the idea. Whenever I start this one is twice the tension, it means that now the length of that string after the stretching is twice the L, or is twice, it's twice the length, the initial length, or the initial natural length of that spring, or that string. So, that's the case we had here. I wanted to show you this. But our formula, this is our L, basically. So this L we have substituted it with this pair. So, that's it. I wish you well.